So today we're going to be solving the chapter 4.1 to 4.3, I think. I forgot what's the chapters in this quiz. But it's the first chapters of chapter 4 quiz. And yeah, it's about moments. hala. The first question is telling us that we have a triangular lamina and it's about vertex A. Which of these forces will make a turning effect on the lamina? So we know that if this is A, we cannot take any point that runs through A. For example, F1 passes through A and F4 passes through A. If it passes through A, immediately cancel them out. It cannot move at all. It will not make any effect. It's almost zero. So now cancelling F4 and F1 from our options, any force that's left that does not pass through A can make a turning effect. So F2, F3 and F5. Let's see. F2, 3 and 5. Next question. So, okay, this question is telling us that you have a force F and it's applied to a plank and can rotate about a fulcrum A. So now it's asking us that the moment of force F is directed. Now for this, we need to do a right hand rule. Or if you actually can't do right hand rule, even though I always prefer to do a right hand rule, draw and this and like connect it to where the fulcrum is. And if it's going like that, it's gonna be counterclockwise. So counterclockwise is positive always. And if it's counterclockwise, like this part by right hand rule, it should be out of the plane of the page, because when you do right hand rule, your thumb is gonna be pointed towards you, which means out of the plane of the page. So next question. And okay, so a force of magnitude 40 is exerted on a square lamina of sides 2 meters. This force creates a moment of negative 40 about point A. P, R, S, and T are all midpoints of the square's sides. So we're gonna hang it from our lamina. We're gonna hang it from our lamina. So let's imagine this is how we're hanging it. And there's your square. Anyways, so now with our square we relabel. So this is point A. Then this is Q, is gonna be like this. This is Q. Then you have R, S, T. T. So we know that immediately we cancel out Q because it is running through A. So Q is big no. And we know that our moment is negative 40. If it's negative, then it has to be from the ones that go clockwise. Let's see, does R go clockwise? R could go clockwise, but it's way shorter for it to go like this than for it to go like this. So you always choose the shortest route. So this one is gonna go counterclockwise, so it's either way gonna give you a positive moment. So R immediately is wrong. And these two are gonna give you negative moments, S and T, because they're both going clockwise. It's faster for them to go like this than to turn all the way like this. Since it's faster, you're gonna choose them since they give you a negative moment. And let's say they give you a point that's not at the middle. You're also gonna have to calculate it. Since the square is 2 meters, this is at the middle, so this is at 1 meter distance. And if it's 40 newtons, you're gonna do 40 times 1 meter. You're gonna get that it is negative 40 moment. But anyways, that we found the answer by cancelling out Q immediately and R because it doesn't go clockwise, and you're either way left with only 2 points, which are your answer. Next question. So for this question, it's telling us ABCD is a rectangle that has sides 10 and 12 as shown below. There's 3 different forces acting on its side. You have F1 that's equal to 8 newtons, and then you have F2 that's equal to 10 newtons, and then you have F3 that is equal to 4 newtons. Now they want the net moment about the fulcrum A. So we know that F2, immediately it's gonna give you 0. Why? Because it's passing through A. So F2, immediately just cancel it out, we don't take it into consideration. We're left with F1 and F3, they both make a moment on point A. So F1, it's gonna go like this, right? It's gonna go counterclockwise. So F1 is positive and F3 is gonna go clockwise. So F3 is negative. Let's calculate each one and add them up. F1 is gonna be 8 times the distance it's moving. The distance is gonna be this. This is your distance moving. This is how far it is away from intersection with this line that has A on it. So this distance is half of 12, which is 6. So you're gonna do 6 times 8 is gonna be 48. That is F1. That's F1. Now, let me just erase a few bits of things so I can make annotations. Now we have F3, it's equal to 4, and it's going, this is the distance, so you have this line. This is the distance between it and the intersection of this line. This is gonna be 5, so it's 5 times 4, which equals 20, but it's negative since it's clockwise, so this is negative 20 for F3. Now 48 plus negative 20 is gonna give you 28, and that's how you get the answer to this question. Let's move on to the next question. Okay, for this question, it's purely right hand rule. Like, you're gonna have to put your hand on the force. Your palm should always face the fulcrum. So the inside of your hand, كف إيدكم, it's to the fulcrum. So this is gonna go like this, which is clockwise and negative if it's clockwise. And if it's clockwise, it's into the plane of the page. This force over here, it's going like, not like this. It can, actually, yeah, it's going like that. Sorry, my bad. So if it's going like this, it's counterclockwise, so it's positive. And if it's counterclockwise, it's out of the plane of the page. Like, just memorize them, I guess, if you don't know right hand rule. Okay, so which of the forces that's acting on this box will produce a clockwise moment on it? Since we have this force is going up, it's not gonna make anything clockwise, since this is the normal reaction, by the way, since this is the fulcrum. But then you have the weight. The weight is like this. The weight, when it needs to go to the fulcrum, it's gonna go like this. So the weight is gonna go clockwise. So if it's clockwise, it's negative. See, clockwise, and the conventional sign, which means the agreed upon sign, is negative. That's it for this question. It's really easy. Okay, so here you have a question about torque again. So we're gonna calculate. So it's telling you that the torque of F1 is, so let's see F1 first. F1 is here, it's about A, right? So this is A. F1 is passing through A. So F1 immediately, don't even think about it, is 0. Immediately. I'm gonna change the color. Yeah. Now you have F2. Where's F2? It's here. This is F2. I'm gonna erase this. So F2 is here. The distance between it and the intersection with A is 6 meters. F2 is equal to 20 newtons. And we need to see its direction. Its direction is like this. So this is clockwise. So it's going to be negative because of the clockwise. And then 20 times 6 is 120. That's how you get this part. Now for F3, we're going to look at F3. F3 is here. If F3 is here, the distance between F3 and A is this. This is 2 plus 10, 12. And F3 is going like this to reach, so it's counter clockwise, meaning it's positive. So we need to do F3, which is, where's F3? F3 is 6 newtons. 6 newtons times 12 is 72. That's how you get this answer. Now for the last part, you're gonna have to add these two up. Negative 120 plus 72. It's gonna give you, I think, negative 48. But let's make sure. And yes, it's negative 48. Next question. Okay, so it's the moment of a couple. Couple forces are, what's it called? Couple forces, they're forces that don't act around a fulcrum, but they act like they're parallel, and they have to be equal in magnitude and in opposite directions. That's how you know it's a couple force. So the magnitude created by the 200 Newton forces is, we need to calculate it. So since you have to calculate a couple always, you need to take one of the forces, any one you want. They're both the same. So 200 multiply by the distance between the two forces. So this distance here. This distance, they told us that the outer radius, the big circle's radius here, this part is 15 centimeters. So if this is 15 centimeters, then this is going to be 15 centimeters because this is a radius. So the whole diameter is 30 centimeters. Since they want it in Newton meters, we need to make this in 2 meters. So let's make it meters. So 30 centimeters is 0.3 meters. And now, using your calculator, you're just going to do 200 newtons times 0.3. You're going to get 60 Newton meters for your first answer. Now, let's go on to the next part. Now, for this part, it's telling you the force exerted on A must be directed. So we want to cancel these forces out. So in couple forces, when you want to cancel a force out, you're going to look to the force closer to the point, which is here in the first part, it's A. The force closest to it is 200 and it's directed rightwards. So A is going to make a force that's 200 but leftward. And now you have 200 newtons leftward for B, but it's closer to it, so that's why you take this one. So B will have to produce one rightwards, that's 200 newtons. And that's just it how you solve this part. So see? Leftwards and rightwards. The magnitude of F is, so we know that F is the force that's gonna cancel out these two. And we know that they're between these two forces. We need to find the force, F. So the distance between these is 10 centimeter radius. So it's 20 centimeters here. So 0.2 meters times a certain force F is gonna give you the magnitude of these two forces, because you're trying to cancel this out. 60. So your force when you do it is equal to 300. And that's how you get it. So it's 300, see? Now you have this question. It's telling you have a horizontal force of magnitude F equals 20 applied to vertex C of a rectangular frame shown below. The magnitude of the force F about vertex A is, so let's solve it. You have this force over here, so you have this force over here, and it's 20. And you know that about vertex A. Vertex A is on this line. You need the distance between this point and whatever is gonna intersect with here, like here. So it's 60 centimeters. We know we need it in meters, so 0.6 times 20. Wait, no, they want it's in, yeah. So yeah, 0.6 times 20, which is gonna be 12 Newton meters. Now, let's move on to the next question. And this is the last question, by the way. Consider two forces, each of magnitude 15 newtons, applied to twist a cap that's 2 centimeters. These are a couple forces. Again, you take any one of the forces you want. Let's take this one. It's 15 newtons, so 15 times the distance between them. It's 2 centimeters, so it's 0.02 meters. And when you solve this in your calculator, you should get 0.3. That's how you solve this question. This quiz is really easy. And yeah, hope you have a nice day. Bye.